All right, let's take a look at these problems 30 through 32. These have the appearance of being these transformations, but they're not, because we don't have an initial point on the graph of f to transform. They're not telling us that the point, I don't know, -1, 4. They're not asking us to transform a single point into. I suppose we could translate the whole table, but we don't know if any of these x coordinates would transfer to x is -1. So I really don't see a way that you should apply the transformations to this table. It could work out, but the table is finite. We may not have the point that we need. It's much easier that we can just do this by substitution. This is the idea that you could have used before you ever learned. No, you're fine. All right, somebody came in and was afraid they were interrupting us, but that's fine. So I'm just going to do a substitution. So I could have done this before I ever learned about function transformations. I'm evaluating this function at -1. So everywhere I see an x, I'm replacing it with -1. So I've got 1/2. Now this f is 3 times x, which is 3 times -1. I don't have an equation for this function f, but I do have a table of values. So as long as this input is one of these x values, I can get an output. +3 times a -1 is -3. So this is saying take the half of some number. And that number, I can come in from this table and read what that number is going to be. It's going to be the output of this function when the input is -3. So when x is -3, the output of this function is -6. That's all I did, was replace this f at -3 with -6. This is the same value here. This function notation is just an advanced notation for the y coordinate. Well, here's the x coordinate. These are the y coordinates. And now we can do this arithmetic and get our final answer. Half of -6 is -3, and -3 plus 1 is a -2. So there's our final answer. We did it by substitution. Let's take a look at 31. We're going to approach it in the same way. We want to evaluate g at -2. This function g, I don't have an equation. If I did, I could just plug in -2 and do the arithmetic. But I do have a relationship that g is related to this function f, and the only thing I know about this function f is just these discrete values. I don't have an equation, I don't have a graph, I only have just a few of these values. So as long as I have one of these values is in my table, then I can use that. I replace x with -2, and we get a subtraction problem. 10 minus some number. That number, I'm going to have to go to the table to determine what it is. And hopefully x equals 0 is in my table, otherwise I wouldn't be able to do it. But it is. When x is 0, f evaluated at 0 is 5. So this is just saying, what is 10 minus 5? That's 5. Because this guy right here is telling us that f evaluated at 0 is equivalent to 5. That's what that is. That's what all of those points are doing, right? This point over here, we didn't use it, but what this is, the information that it's telling us is when you evaluate this function when x is 4, you get 0. That this graph is passing through the point 4, 0, or 4, 0 is a point on the graph. We don't know if this function is just only those points. We can't connect the dots because we don't know enough information about this function f. So anyway, this is just substitution is my point. So let's substitute here. G evaluated at 2. So I have 2 times 2, which is 4. And 4 minus 1 is 3. And hopefully I can see that in the table. Hopefully the table will provide us what f evaluated at 3 is. And I think it does. F evaluated at 3 is negative 6. So I've got negative 3 times the negative 6 plus 3. So 18 plus 3 is 21 if I've done my arithmetic correctly. So I think that's it for this video. Yeah.